This screencast is a screencast to show you how to do the various cost-benefit analysis techniques that we've been talking about in the unit. Firstly, I want to talk to you a little bit about the how to calculate the costs in the first place. So if I quickly click through onto this via the Excel spreadsheet, this Excel spreadsheet is actually available to you as one of your resources for your assignment. I expect you not to use the same calculations, of course, but it will give you a starting point to work out the calculations. So you can see that you can look for, you've got development costs and you've also got projected annual operating costs. So these development costs can include things like personnel, other expenses, new hardware, software, and you'll end up with a total development cost, which is a one-off amount. You'll also end up with some annual costs. Now these may well change from year to year depending upon things like expected rise in prices of personnel, rise in prices for expenses, etc. So you need to calculate, you may not only calculate it for 1 year, you may calculate that for a number of years. Once you've actually identified these development costs and annual costs, you can then go on and start working out your payback analysis. So the payback, there's two different types of analysis in here. One is the payback period and one is the return on investment, or the simple return on investment. So this says project A, so often we use this to compare two different projects and work out which one is the better project as far as cost benefit. But we can also do this just for one project to work out whether it's feasible to go ahead. So you can see that with this we start with year zero. Now year zero is while the actual project is being developed. So the costs in year zero will always be the development costs, and there won't be any benefits to the business while it's actually being developed. So we can write in the development costs and then the benefits, and you can see that we've estimated the costs for the next 6 years for this particular project and the benefits for those years as well. Now what we need to know is whether it's going to be worthwhile doing this project, which it's not necessarily obvious to see whether this is going to be reasonable or not. So the first thing we do is our accumulated costs for year zero is just the development costs. So we can put equals this cell. This is much faster than you'd expect it to be. So there's our accumulated costs. And you can see that our accumulated costs for the first year is going to be our development costs plus our year one costs. So we can put equals this plus this. Now once you've actually worked that out, you can then just use this little corner tag to fill down, and it will give you the accumulated costs for all of those years. So the accumulated cost at the end of 6 years is $523,085. Okay, let's work out the accumulated benefits now. Well, it'll just be the same process. So equals this, which is 0, and then equals the 0 plus the benefits for the first year, and then we can fill this down as well, and you can see these benefits growing. Now you can see at the end we've got a $1.2 million benefit, accumulated benefit, for a accumulated cost of 523,000. So this particular project would be worthwhile doing. What we would like to work out though is the return on investment, and the return on investment is the accumulated benefit. So our return on investment, ROI, over 6 years, okay, will be the benefits take away the costs, so equals, I'm going to put this in brackets, this take away the costs divided by the costs. Okay, so, and it's given it to me in dollars, which is not what I wanted. So I'll just fix that. Shouldn't be in dollars, should be percentages. So there we go, 129%. Is that right? Take away that over that. I'll just check that, sorry. Yes, I thought that was right. So this has actually got a fantastic return on investment of 129%. Over 6 years. Now that's over 6 years, but what if we're expecting it to be replaced within 3 years? Then what we would have to do is work out the accumulated benefits for the 3 years, take away the accumulated benefits as accumulated costs for 3 years over that, and that the return on investment may well be a lot less. So it really depends on how long we're expecting this system to to be useful, and when we're going to have to replace it. Now we can also work out the payback period, which is when the accumulated benefits equals the accumulated costs. So you can see that in this time between 2 and 3 years is where our benefits actually overtake our costs. So we could do a calculation there as well to work out our payback period. Now, the most complex part, of course, is our net present value calculation. And this is the one that usually concerns students. It's not actually all that difficult. So our net present value calculation just means that we put in all of the benefits. So you can see that our benefits, we have year 0, 1, 2, 3, 4, 5, 6 here, and our benefits across the top, and our development costs, which appear in year 0, and our ongoing costs. So we've got our ongoing costs here, which we've calculated. And then what we do is we make an adjustment for the time value. And so, which says that if $150,000 now is worth more than $150,000 in 6 years. So we work that out. We go through that with our factors. So the factor in year 0 is always 1. So we can put down the factor 1 here. But we do a calculation. You can have a look at your notes for the factor for years 1, 2, 3, 4, 5, and 6, and this will be the amount that, or the factor by which we're going to reduce those benefits that is going to take into account the time factor of that money. Okay, so the formula for that equals, now it's 1 over brackets 1 plus the percentage value. So the percentage value is 0.09 because we're using a 9% factor for in this case, and then to the power of the year that it's in, or the number of years. So we can use this here, and let's close that bracket because that's all over 1 all over all of that. Okay, so that's our factor formula, and if we press enter you can see that it's reduced that 1 by a little bit, and what we can do is we can then fill across, and we don't have to do that calculation all the way across. We can also fill down by clicking on here and then pressing Control and pressing this, and then clicking on this cell, and then pressing Control and D. Okay, that didn't work. Okay, it's because it's C5. So what we want is it to be C1. Okay, so let's just change that to C1. You could put in the formula again, I was just trying to save some time. And then we can fill across this as well. Okay, so now we've got our factors. What we need to do is actually multiply our actual benefits by the time factor. So this cell, the present value cell, will be the benefit amount times the factor. And you can see that this is reducing this amount. So in other words, it's saying if I had $150,000 a year ago, it's really only got the buying power of 137,000 now. Okay, so we can scroll across, fill across here, and you can see that that's adjusting each of these, and you can see that they're similar amounts. Okay, in the same way, we want to multiply our benefits, our costs. So let's say our cost times the factor. Okay, there's our cost. Okay, fantastic. Now, we've now got the time adjusted costs and the time adjusted benefits. We can do this a couple of ways. Either we can say benefits take away costs and have that net present value at that particular time, or we can multiply, add up, sum all of these amounts to get the total present value of the benefits for this project. So what I'm going to do is say equals sum of all of these amounts. Okay, that's just going to add them all together. And that's the total benefits of this project. Now, let's have a look at the total costs. Sum of this to this, and there's the total costs of this project, plus, we didn't actually add this, our 418,000. So we just put equals this amount, and this sum should actually be from that amount, from that cell rather than just these cells. So let's make it from C7. Okay, that's not right. No, that's not right. Equals. Let's do that one again. Equals sum of this one to this one. There we go. It goes from B. Okay, so now you can see that the total benefits of this project are this amount, and the total costs of the project are this amount. So therefore, the net present value, which is what we wanted to find out, equals this take away that. Okay, so the net present value, the net present value of the project is this, and any project with a positive net present value is feasible over this time period. Now, of course, if you're asked to work it out over 4 years, maybe that would be different. You're usually told how long the system is expected to last, and you would work out the net present value over that amount. Now, an alternate way of doing this, of course, is to just say benefits take away costs. So this equals benefits take away costs. And then let's drag this across. So what all of these is, it's this one take away this one is that, this one take away this one is that, and so on. And so we can actually work out the cumulative net present value by saying equals, and this is another way of working out when we've got our break-even point, equals this plus this. Okay, can you see it's negative still? So in other words, we haven't paid for the project yet in year one. We have paid for the project by the end of 2. Is that right? C, no, that's not right. Equals, that's not right. So our cumulative net present value equals this, and then this will equal that plus that, and then we can actually fill across. Okay, so you can see that we're still negative in year 1, we're still negative in year 2, we're still negative in year 3, but only just. And so by year 4, we're actually starting to make money on this from this project. But we're not actually making it until year 4. So if you had 2 different projects that were both had a positive net present value, they both had similar returns on investment as far as a percentage. And one had a payback period of 2 years and one had a payback period of 4 years. You would probably think that the 2-year project would be a smarter option because you would start making money on it much faster. I hope I haven't confused you. I am going to provide these calculations for you on the MySCU site, so you can go through and do them at your own pace. But just be aware that for your assignment, what you'll need to do is show that you can do at least 2 of these techniques to work out whether a project is feasible.